Welcome to the video lesson on simple Punnett squares. And by simple Punnett squares, what we mean by that is that these are just single crosses. We'll start off with some easier examples on doing Punnett squares, and we'll get more complicated in later lessons. Punnett squares were invented by Reginald Punnett, who is a big fan of Gregor Mendel, and he came up with a way by which to calculate and express the percent probability of the genotypes and percent probability of the phenotypes of particular crosses. When we say cross, we mean to take one individual and cross it or mate it with another individual of a particular trait that have particular traits. To start off with, let's use an example of the human widow's peak. Having a widow's peak, which is this point in the hairline here. So individuals whose hairline comes together in a point like I'm showing here have what is called a widow's peak. That is a dominant trait in humans. And so widow, capital W, we would give that the capital W because that trait is dominant. Having a straight hairline, a hairline that goes straight across instead of coming down at a point, would be the recessive trait, and so we would give it the little w. We would not use S, we take the dominant trait, and because it's recessive, we make it its lowercase letter. In this example, we're asked for the male to be, this is a symbol for male, to be heterozygous for widow's peak. What does that mean? That means they would have different genes for this. That means they would have a capital W and a lowercase w. So heterozygous, dominant, with a female that's also heterozygous, dominant. So the female also has a genotype that is big W, little w. When doing the Punnett square, you take and put one of the individuals on the top of the square, and you take and put the other individual on the left side of the square. In this case, we'll put the male, whose genotype is big W, little w. So we take and put one of each of his alleles on top of each square here. And then we have the female, which is also big W and little w. And now we have our square set up by which we can figure out and calculate the resulting genotype and phenotypes for this cross. Well, what would happen if they inherited a big W from the dad and a big W from the mom? Well, of course, you would end up with a big W offspring. If you inherited a little w from the dad but a big W from the mom, you would end up with a big W, little w. And because the big W is dominant, we would write that first. What if you ended up with the big W from the dad and the little w from the mom? That would again give you the heterozygous dominant, which would be big W, little w. What if you inherited the little w from your dad and the little w from your mom? Well, that means you would get a little w from each, and you would end up with a homozygous recessive. Now filling in our genotypes, you would end up with a 25% chance, 1 out of 4 chance is 25% chance of being big W. You can see that we have 2 out of 4 chances in getting a big W, little w. So that would be a 50% chance of that. And we also have a 1 in 4 chance of getting a little w. And so that would be a 25% chance. A nice check here is to always make sure that your percent probabilities add up to be 100. Otherwise, you probably made a mistake. These would be the resulting genotype percentages. What are the resulting phenotype percentages? Phenotype is the physical appearance. How many of our 4 would end up showing a widow's peak? Well, any that have a big W in them would show this trait. So that would be this one, and this one. So 3 out of 4 would show widow's peak, and therefore a 75% probability of showing widow's peak. Only 1 out of the 4 shows the homozygous recessive trait for a straight hairline. And so straight hairline, 1 out of 4 would be 25%. And that's how you do a Punnett square. Let's do another example where we take a look at the human trait of having a Roman nose. Having the Roman nose is the dominant trait, and a Roman nose is where you have this kind of arch to your nose like shown in the picture on the left here. The recessive trait is having a straight nose, straight down from the forehead. As mentioned, having the Roman nose is dominant, so we will assign that the capital R. Having a straight nose is recessive, so we would assign it the opposite of the capital R, which is the lowercase r. We are asked to cross a heterozygous male for Roman nose, so that would be the genotype big R, little r, which would be heterozygous dominant, with a straight nose female, and the only way she could have a straight nose is if she was homozygous recessive, little r, little r. So we want to take and put, for example, we can put the male on the top of the square and the female on the left of the square. It doesn't matter, you can do it the other way around too. Assign the appropriate genotypes above each square. So heterozygous male means 1 of each. And then we have the straight nose female, which would be homozygous recessive, so little r for her to the left of each of her squares. Now let's take a look at the possibilities here. We have a big R crossed with a little r, so that would give us big R, little r for this offspring. Little r crossed with little r would give us little r for this offspring. Big R with little r would give us big R, little r for this offspring. And little r would give us little r for this offspring. Now for the resulting genotypes, you can see we only have 2 possibilities on our square. We have our heterozygous dominant in 2 cases, and we have our homozygous recessive in the other 2 cases. So for resulting genotype, we have little r, big R, little r as 50%, 2 out of 4. And we have little r being 50% homozygous recessive, 2 out of 4 on this as well. So, what is our resulting phenotype percentages? Well, for the Roman nose, you have to have the big R to show it. 2 of our 4 have that, so that would be a 50% probability on having Roman nose. And to have straight nose, you have to be homozygous recessive, and we have 2 out of the 4 with that. And so we have 50% probability of having straight nose as well. We add up our percentages and make sure each adds up to 100, which they do. So we feel good about our answer. and we feel like we did the Punnett square correctly. This will do it for 2 examples on doing simple single cross Punnett squares. More to come as we practice this more in class tomorrow, and we'll get into more complicated types of Punnett squares and crosses in a future lesson.